Hi students, in this video I'll be going through the 2019 O-Level Mathematics Paper 1 question 16. Alright, so this is a question regarding congruency. Okay, let's read the question. Okay, so we are given the diagram over here as you can see. Okay, then TA and TB are tangents to a circle with the center O. Okay, so we are asked to show that triangle OAT and triangle OBT are congruent. So give a reason for each statement you make. Right, so before we do the question, I would like to just go through all the different tests for congruency. Okay, so if you recall, the first test would be SSS. So 3 pairs of corresponding sides, they are equal. Okay, then the second one would be SAS. 2 pairs of corresponding sides, they are equal, and the included angle, which is the angle in between the two sides, okay, must be equal. Okay, then the third test would be the AAS test, right? So 2 pairs of corresponding angles and one other corresponding side, okay, must be equal. Okay, and then finally we have the RHS test, okay, which stands for right angle hypotenuse side. Okay, so the two triangles must be right angle. Okay, the length of the hypotenuse must be the same, and one other side, okay, one other corresponding side has got to be the same length, right? So these are the 4 tests for congruency. Okay, so looking at this diagram, whenever you have a question like this, you should try to identify the things that are obviously of equal length, okay, or angles that are equal. Okay, so over here you can see that OA and OB, right, are actually the radius of the circle. So this length has got to be the same already. Okay, so OA has got to be the same length as OB. Okay, so we have already gotten one pair of corresponding sides that are equal. Okay, then you can see that for the two triangles OAT and OBT, right? Okay, it's actually you can actually see that OT will be a common side, right? So OT is a common side. Okay, so now you have two sides that are the same already. Okay, so you should either be thinking about SSS or SAS, right? Okay, then you can see that actually we can identify the third side that is of equal length, which is AT. Okay, it's the same length as BT, okay, by the property of tangent from external point. So the external point that we are talking about is T over here. Okay, so from this external point T, when you draw two tangents, okay, to touch 2 points on the circumference of the circle, then those two tangents, okay, from the external point to the point that is on the circumference of the circle, okay, that length is going to be equal, right? So in this case, AT will be equals to BT. Okay, so we actually can use SSS already. Okay, but actually for this question, you are actually able also to use other tests. Okay, so for example, you can also use SAS test. Okay, why can we use SAS? Because by the property of tangent perpendicular to radius, okay, these two will be 90 degrees. Okay, these two is going to be 90 degrees. Okay, which also means that we are actually able also to use RHS test for this one. Because if we have 290 degrees, then the two triangles are right angle. Okay, the hypotenuse would be the OT, right, which is a common side, and then you can use the radius. Okay, OB equals to OA as the other side. Okay, so you can actually also use RHS test. Okay, and you can actually also, for this particular question, it's very unique, this question whereby you can actually use all the different tests. Okay, all are applicable depending on how you present your solution. AAS will also work because for this particular case, for this tangent from external point, if you draw a line from the center O to T, it's actually going to bisect this angle ATB, right? Okay, it's going to bisect it over here. Okay, so if these two angles are the same, then technically we can also use AAS because we have these two angles the same, and then the two right angles, another pair of equal angles. So you can also use AAS test. Okay, so this is a rather unique question whereby all the 4 tests can actually be used. Okay, which means that to get all the 3 marks, it just depends on whether you have presented your working properly or not, right? So for this question, I'm just going to present one, but you can actually present the rest on your own now. Okay, you go and try and practice how to present. Okay, so I'm going to use the first one, SSS test. Okay, so because I think that is the easiest of all the 3 tests. Okay, so the first one that we can write would be OA equals to OB. Okay, so as mentioned, they are both the radii of the circle. Okay, so we can write radii of circle. All right. Okay, then the second one would be AT equals to BT. AT equals to BT. Okay, so this one would be tangents from external point. External point. Right, then finally, OT is a common side, right? OT is a common side. Okay, so from here we have our S already, okay? We have shown three pairs of corresponding sides that are equal. Okay, so then we can conclude, therefore, triangle OAT is congruent to triangle OBT, and the test that we are using is the SSS test. Okay, so this is how you present your working. Okay, you've got to give a reason, okay, for each statement you make. Okay, so each statement should come with a reason explaining why it's equal. Right? Okay, let's look at part B of the question. Okay, just a 1-mark question. Okay, but it requires you to think a bit. Okay, they say that there's this point P that lies on the circumference of the circle, so that triangle APT is congruent to triangle BPT. So on the diagram, they want you to mark two possible positions for point P. Right, so where will point P be? Okay, so the triangles are almost similar to the ones that are in part A. Okay, so remember in part A, we have already shown that this side, right? Okay, this side, tangent for external point, equals to this side. Alright, then we have also identified that this angle is the same. Okay, so now we need to identify the point P, possible location for the point P, right? Okay, such that the two triangles APT and BPT are equal. Okay, so I think for this question, it's actually rather obvious where the answer is going to be. Okay, so one of the position of P is going to be over here. Okay, so why does this work? Okay, so if I'm going to form the triangle APT, so let me just form it. Okay, over here, and BPT over here. Okay, so form the triangles, right? These two triangles are definitely going to be congruent. Okay, because we can actually use the SAS test. Okay, so AT is equals to BT. So we have one pair of corresponding sides that are equal. The included angle, okay, BTP and ATP, they are equal. Okay, why are they equal? Because of the property tangent for external point. Or even if you don't know this property, okay, from part A, after you have proven congruency, right, that triangle OAT and OBT are equal, right? Then by virtue of the two triangles being congruent, angle ATO will be equal to angle BTO, right? Okay, so these two angles are the same. Then if you add a point P there, okay, it's obvious that TP is going to be a common side, correct or not? Okay, so TP is going to be a common side. So triangle APT will be congruent to triangle BPT. So one of the points will be over here. Okay, so where would the other point be? Okay, so if you do a little bit of thinking, you should be able to realize that the other point is actually going to be over here at this side. Okay, so you're going to extend using a ruler with a straight line. Extend this line TO to touch the circumference of the circle. It's going to be actually over here. Okay, so use your ruler to draw, okay, in your exam. Okay, so if you join it together, okay, you'll get the triangles like this. Right, so I'm going to erase away this one. Okay, erase away this one. Okay, so you can see that now triangle APT will be congruent to triangle BPT. Okay, why is that so? Okay, same thing. AT equals to BT. So one pair of corresponding sides. Angle ATP equals to angle BTP. Okay, so those two angles are equal. And then same thing, PT is going to be the common side. So by SAS test for congruency, these two triangles are going to be congruent. Okay, so the two positions for P will be one over here and the other one. Okay, extend the line TO to touch the circumference and it will be at the other side. Okay, Okay, so this is a paper one question on congruency. It's not too difficult, but it shows that what you need to do is you need to know the test for congruency very well. And then when you start the question, go about trying to identify sides or angles that are equal. And then you start to narrow your choice of test from there. But in this case, like what I mentioned, this question is unique whereby all four tests can actually be applied.